Hello everyone. In this lecture, I am going to discuss the partial fractions and integration of rational functions. I am Dr. Bharat Kesari Swai, lecturer in mathematics, Agarpada College, Odisha. So let us start. So what is rational function? A function of the form px by q of x, where p of x and q of x are polynomials, is called a rational function. Okay, so a rational function means it is of the form p of x divided by q of x, and here both p and q are polynomials. And we should note here that if degree of p of x and degree of q of x, if degree of p of x is less than degree of q of x, then the function is proper rational function. And if degree of px greater than equal to degree of qx, then it is improper rational function. Clear? Now come to the next page. So what is improper rational function? So if the rational function is improper, then divide. That means we know that improper rational function means your degree of p of x is greater than degree of q of x. So therefore, if we divide your p of x, if we divide p of x by q of x, because p of x is means degree of p of x is more than degree of qx, then we should have some quotient here. Let it be theta of x. So if I divide it, suppose it is theta of x, and if I multiply q of x with theta of x, then suppose it is another function, that is f of x, and the remainder is r of x. Remainder is r of x. So your p of x will be q of x into theta of x plus r of x. Is not it? So therefore, we can you can write your p of x divided by q of x like this. P of x divided by q of x like this. Theta of x, this is your quotient, and the remainder will be r of x. So your p of x by q of x will be theta of x plus r of x divided by q of x. Is not it? So now in this case, your r of x divided by q of x, it will be a proper fraction, because if we divide it, then the r of x is remainder. That means the degree of r of x is less than q of x. If it is more than q of x, if it will be more than q of x, then we can divide it again. So therefore, your remainder r of x, degree of r of x, should be less than q of x. So therefore, it is a proper fraction. So whenever we have a improper rational function, then we can write this in the form like this here, theta of x plus r of x by q of x. So from the improper rational function, we can get a your proper rational function. So it is sufficient to study a proper rational functions. Okay, now come to the next page. So if we have a proper rational function, then how we can write this function as a sum of simpler fraction? We can write the proper rational function as your r of x and q divided by q of x as a sum of simpler fraction, and that is called partial fraction, which can be integrated easily. Okay, so what we have to do in case of means in your fractional fraction, we have to do means we have to write this function, then we have to write the proper rational function as a sum of simpler fraction, Okay, so in the next page we can come here. So whenever we have a non-repeated linear factor, suppose okay, so one thing we have to note that checking your denominator in the proper fraction, checking the denominator q of x, always see your q of x, the form of q of x. Okay, so in every form, in different form, there should be different type of partial fraction. So first case is what? Non-repeated linear factor. Suppose q of x, that means your denominator of the proper fraction. If the denominator is in the form like this, non-repeated linear factor, this is a linear factor, this is a linear factor, and this is a linear factor, a1x plus b1 into a2x plus b2 into like this up to anx plus bn. Suppose these are the linear factors. That means your denominator is in the form of product of linear factors. That must be non-repeated. Okay, non-repeated linear. This is one of the linear factor. Again, this is another linear factor like this. These are not repeated. Okay, so if not repeated, your Rx by Qx, that means your proper fraction can be written as a sum of simpler fraction like this. That means we should write like this. A1 is a constant, so A1 by first factor, then A2 by second factor, like this, An by last factor. Okay, so suppose we have three factors, then only we have to write what? A1 by A1x plus B1 plus A2 by A2x plus B2, then plus A3 by A3x plus B3. Suppose we have two factors only, then A1 by A1x plus B1 plus A2 by A2x plus B2. That's it. Okay, so like this we can write the proper fraction as a simpler fractions, and after that we have to determine your capital A1 and A2. Okay. Okay, next is case 2. If repeated linear factors are there, suppose the denominator is having linear factors but repeated. That means here q of x is what? Here q of x is ax plus b into again ax plus b like this, and it has n factors, so it is repeated n times. That means same factor are repeated n times. That's why q of x is ax plus b to the power n. Ax plus b to the power n. Isn't it? That means we have n factors but they are repeated. Linear factors but they are repeated. So in that case, we have to write your Rx by Qx like this: a1 by ax plus b, then a2 by ax plus b whole square, and up to an by x plus b whole to the power n. Okay, so we have to check what is the repetition, how many times your factor is repeated. Is not it? Suppose your q of x is suppose your q of x is q of x q of x is equal to ax plus b q, ax plus b whole q. Then what we have to write? Rx divided by q of x is equal to a1x, means a1 divided by ax plus b, because degree is 3, so ax plus b, then a2 by ax plus b whole square, then a3 divided by ax plus b whole cube. So up to third degree we have to write. You know it. So how many times it has been repeated we have to check, then that much term we have to write. Clear? Now come to the next page. So case 3, non-repeated quadratic factor. Suppose in the previous two cases the factors were linear, but in this case the factor is a quadratic factor. So suppose if it is quadratic, then we have to write like this. The form is in the form ax plus b x square plus bx plus q. If it is quadratic form, okay. Suppose we have a form like this. Suppose your qx is in the form ax plus b into another quadratic form is there, x square plus px plus q. Okay, so qx has two factor, one is linear and another is quadratic factor. Then what should be the decomposition? That means your rx by qx can be written as some constant, because it has a linear factor. So for linear factors only write a1, so a1 by ax plus b. Then plus for the factor, means here for the quadratic factor we have to write what? a2x plus a3, a2x plus a3, another constant, divided by your quadratic factor x square plus px plus q. Okay, x square plus px plus q. Clear? So for linear factor only constant will be there, and for quadratic factor we have to write like this, a2x plus a3. Okay, so here it is written ax plus b. So in place of a, b, we can write a2, a3, any constants are there. Okay, come to next page. Another case is repeated quadratic factor. If it is repeated, quadratic factor is repeated, then same case, same in like the previous cases, you can take up to the degree. How much degree are there, we have to check. So here degree is n, quadratic factor, and degree is n. So we have to go up to nth term. So for first it is quadratic, so a1x plus b1 divided by x square plus bx plus q. Then for second, if it is a2x, another constant, a2x plus b2 divided by x square plus bx plus q square whole square. So similar in the same way we have to go up to a n x plus b n divided by x square plus bx plus q whole to the power n, because it is degree n, so we have to take up to x square plus bx plus q up to the power n. So we have to check here, we have to see here And you have to notice that your numerator is a linear factor, not only a constant but is linear. A1x plus b1 type, ax plus b. This type of form we have to take in numerator. But in case of linear factor, it is only some constant a. This is the difference. Clear? Now, method of finding constant. So these are constant. That means a1, b1, a2, b2. These are constant we have to determine. So how to determine that? So express the given fraction as a sum of partial fraction. Already we have discussed it. This is the first point. And second is multiply both sides by the denominator q of x. The denominator we have to multiply in both sides so that it will be cancelled. Then compare the coefficient of like power of x. Okay, we can take the coefficient of like power of x or substitute the suitable values of x so that we can find the value of the constant. Okay, so there are two methods to find out the constants. One is compare the coefficients of like power of x in both the sides or substitute suitable values of x. Now solve the resulting system of equations. After getting the coefficients, just solve the resulting system and we can find the constants. Clear? Okay. So we will check an example. We check an example so that we will be more clear. The question is we have to integrate 4x plus 5 divided by x square plus x minus 2. So this is the question. Okay. So we have to use, first check whether it is a proper fraction or improper fraction, because degree of numerator is less than degree of denominator, so it's a proper fraction. Okay, and directly you can solve it. So for the partial fraction we have to check the denominator. So denominator is x square plus x minus 2, and if I factorize this, it will be x plus 2 into x minus 1. Is not it? X plus 2 into x minus 1. Middle factor we can use. And see, so both the factors are linear. Both the factors are linear. So that's why for the partial fraction, what should I write? Because both are linear, so we have to only write the constant only. So for one constant is for first factor and second constant is for second linear factor. So therefore your question, that is your 4x plus 5 divided by x plus 2 into x minus 1, can be written as some constant by first factor x plus 2. This is your x plus 2, and for second factor x minus 1, some constant into some constant divided by x minus 1. So just write like this. Okay, so after writing this, just add it. And what will be this? What is your LCM? X plus 2. LCM is x plus 2 into x minus 1. And in your numerator, it will be what? A into x minus 1 plus b into x plus 2. B into x plus 2. Clear? Now, and both the sides, your denominators are same, x plus 2 into x minus 1. So they are not zeros. Just multiply on both sides, x plus 2 into x minus 1, or you can cancel it also. And come to next page. So after cancelling the denominator, we can find what? This is 4x plus 5 in the left hand side, and the right hand side it was a into x minus 1 plus b into x plus 2. Now from this 4x plus 5, okay, so from this just multiply this or compare the like power of x or putting the suitable values of x. What is easy for you, you can do this. So if I put x equal to 1 here, if I put x equal to 1 here, so that will be 0. And if I put x equal to 1 here, so in everywhere just put x equal to 1, because it's an equation, it will be equal for all x. So if I put x equal to 1, then in your left hand side it will be 4 into 1 plus 5, that is your 9, is equal to, on the right hand side it will be 3b. It will be 3b. So your b, the value of b equal to 3. And to find the value of a, just put here x, which just cancel it. To cancel it, put x equal to -2. So it will be cancelled and we can find the value of a. So if I put x equal to -2, then your left hand side will be 4 into -2, 4 into -2, that is your -8 plus 5, that is your -3, is equal to -2 minus 1 -3 into a. So -3 equal to -3a, and a will be equal to 1. So we got the value of a and b, 1 and 3. This is one of the process. Otherwise, you just multiply. It is your multiply multiply the right hand side, that is as a ax minus a, and plus bx plus 2b. And if I compare the coefficient of like power of x, that means in the left hand side the coefficient of x is 4, and the right hand side coefficient is, on the right hand side coefficient of x is what, it is a here and it is b here. So we got one equations, means you're comparing the coefficient, a plus b will be equal to 4. A plus b will be equal to 4. Okay, and comparing the constants, what are the constant? Minus a here and 2b here. So minus a plus 2b minus a plus 2b is equal to, in the left hand side constant is 5, so it will be 5. So minus a. So we got two equation. One is a plus b is equal to 4, and another is minus a plus 2b equal to 5. And we have to solve these two equations to find out the values of a and b. How to solve it? Just add, because here it is a, here it is minus a. So if you add two equations, if we add two equations, so a and minus a will be cancelled. So it will be 2b plus b, 2b plus b. So 2b plus b means 3b. So 3b equal to 9, 3b equal to 9, and your b will be 3. The value of b will be equal to 3. So already we have got. Okay, so this is, and again solve for a, and again solve for a, means cancel b, and just put the value of b here. B equal to 3 means, and put the value of here, value of b here, so you can find a equal to 1. A equal to 1. Okay, so this is another method to find out the value of a and b. So what will be easy for you, you just adopt it. Okay, compare the like power of x, otherwise put the suitable values of x to find out the constant values. Okay, so after getting constant, we can easily integrate. Because in the previous case, this is your function, integration of this, and integration of this means integration of this, we have to integrate, and integration of this function means integration of this and integration of this. Is not it? Integration of this means it is your dx. Integration of this means integration of a by x plus 2 plus b by x minus 1, and that is equal to integration of a means what? Already we have got 1 by, the value of a is 1, so 1 by x plus 2 dx. plus b, the value of b is 3, so 3 by x minus 1 dx, and just integrate it. What is the integration? This is ln x plus 2 and this is 3 into ln x. So just this is the answer, ln x plus 2 plus 3 into ln x minus 1, and plus c is the integration constant. Plus c is the integration constant. So after getting constant, it will be very easy to integrate the given fraction. Okay, so come to this is another example. So question is integration of the question is okay. So question is integration of this example 2, integration of dx x square minus a square, is not it? So you just this is another proper fraction. So using partial fraction, you just write like this. This is 1 by 2a and into 1 by x minus a minus 1 by x plus a, is not it? Because x square minus a square, for x square minus a square we can write this, because it is a square minus b square formula. So x square minus a square means x plus a into x minus a. And if I write like this, 1 by x minus a square can be written like this. And if I integrate this, so it can easily integrate. It can be easily integrated. That means integration of this, integration of 1 by x square minus a square, that means integration of 1 by x minus a, integration of 1 by x plus a. That is your ln x minus a, that means it will be 1 by 2a into ln x minus a minus ln x plus a. And if I solve it, we can get the answer like this. Clear? This is example 3, where the linear factors are repeated. We know that when fraction means your denominator linear factors are repeated, then how we decompose the denominator, how we decompose the denominator. So what are the factors? What are the factors here? One is x plus 1 and another is x minus 2. Just see here. One is x plus 1, another is x minus 2. But x minus 2 is not repeated. Repeated factor is what? X plus 1. Repeated factor is x plus 1. So x square divided by x plus 1 whole square into x minus 2. And that will be equal to a by x plus 1, because it is repeated. We have to go up to second degree, because degree of x plus 1 is 2. Degree of x plus 1 is 2. This is repeated. So up to second degree we have to go. So 1 by a some constant by x plus 1 plus some constant by x plus 1 whole square. This is for this factor. These two terms for the factor x plus 1. And x minus 2 is not repeated. Therefore, some constant c divided by x minus 2 only. Clear? This is the decomposition. Now, what we have to do? Integration of this will be integration of a by x plus 1, integration of b by x plus 1 whole square, integration of c by x plus x minus 2. And we have to determine a, b and c using the previous method. What we have to means what we have discussed on again already discussed. That means using your comparing the like power of x or putting the suitable values of x. Okay, so clearing the fraction, what we got here? Clearing the fraction, we got here x square is equal to a into x plus 1 and x minus 2, b into x minus 2, c into x plus 1 whole square. So to find the value of a or b or c, just see x equal to minus 1 here, because x plus 1 is here and x plus 1 is here. If I put x equal to minus 1, then these two factor will be cancelled. Only term will be there, b into x minus 2. So therefore, you can find the value of b. Is not it? So therefore, put x minus 1, put x equal to minus 1. So this will be 0, this will be 0, only minus 1 into minus 2, minus 1 minus 2, that means minus 3. So minus 3b equal to minus 1 square. In the left hand side it will be minus 1 square, that is 1. So 1 by 3 minus 1 is equal to minus 3b. So b equal to minus 1 by 3. Similarly, to find value of c, put x equal to 2, because here x minus 2 is there, x minus 2 is there. So if I put x equal to 2, so this term and this term will be cancelled, only c term will be there, only third term will be there where c is present. So therefore, if I put x equal to 2, in the left hand side it will be 2 square, that means 4, and the right hand side it will be 2 plus 1, this is 2 plus 1 whole square, that means 3 square, so 9c. So the value of c will be 4 by 9. Is not it? Is not it? It's very easy. Now for the value of a, there are two factors, so it is not easy to put a suitable value. So just compare the coefficient. So coefficient of x square here is 1. Coefficient of x square is 1 here in the left hand side, and the right hand side it will be, if I multiply these two factors, it will be what? A into x square. If I multiply two factor x square, and that is your x into 1, then minus 2, minus 2x, again x, so minus x and minus 2. So if I multiply these two factor, we will get like this: x square minus 2, and one is x into 1 and another is minus 2 into x, so minus x only. So if I compare, and here also x plus, means we have to compare the power of x, means we have to compare the coefficient of x squared, is not it? So here c into x square, because it is x plus 1 whole square, so it is x square plus 2x plus 1. Now compare the coefficient of x square on the right hand side. So right hand side means here it is a and it is c only, so it is a plus c. In the right hand side it is a plus c, and the left hand side the coefficient of x square is 1, so it is 1. A plus c is equal to 1, and c already we have got the value of c, that is 4 by 9. So what will be the value of a? A will be 1 minus c, so c is 4 by 9. Okay, so the value of a will be 5 by 9. Okay, so the value of a is 5 by 9. Now we got all the values of constants a, b and c. Just put here and just integrate here. Okay, so this is your ln of x plus 1, and here you can write x plus 1 to the power minus 2 plus 1 divided by minus 2 plus 1, and this will be ln x minus 2, and this is your result. Clear? And here another example, that that one is quadratic factor and another is linear factor. Whenever we have the denominator like this, the denominator having two factors, one is linear factor and another is quadratic factor. So therefore what we have to write? Your given fraction, we have to write like this: for linear factor, some constant by linear factor, c by x minus 1, and for quadratic factor, that means x square plus 2 is your quadratic factor. So for quadratic factor we have to write ax plus b divided by this. Clear? And now come to the procedure, that compare the like power of x. Okay, all these things we have to do. Okay, clearing the fraction, your left hand side is equal to right hand side like this. Now, and so putting x equal to 1, we can find the value of c here. C is equal to 2, and comparing the coefficient of x on the left hand side and right hand side, That means comparing the coefficient of x square, comparing the coefficient of x, and comparing the constant. Okay, so we will get a equal to 0, b equal to -1. And after getting all these constants, we can integrate easily. These are the answer. Clear? Is there any doubt? You can ask me. Okay, come to next page. This is one of the improper rational function that we have to integrate, because in the numerator it is degree of x is 2, and the denominator also degree of x is 2. So the degree of numerator is equal to degree of denominator. So the function means your function is not proper. The rational function is not proper. So we have to divide. I have to divide like this. We can write your function like this. Okay, just divide x square. So since it is not proper, we can write like this. 4 plus means just divide, your x minus 3 means your 4x square. Just divide. What we will get? 4x square divided by x minus 3 into x minus 1. Divide here. Okay, so what will be your quotient? Quotient will be 4, and the denominator will be the remaining term. We don't know. Okay, but like will be like, means quotient will be like this: 4 plus something, 4 plus something. So but factor will be what? But factor will be x minus 3 and x minus 3 and x plus 1. So we take 4x square by x minus 3 into x plus 1 as a proper fraction, sum of proper fractions. 4 is constant and proper fraction. So now clearing the fraction, we will get 4x square is equal to 4 into x minus 3 into x plus 1, a into x plus 1 because it is linear, then b into x minus 3. Okay, now compare the coefficients. Or setting the value of x. You can adopt any procedure. So setting x equal to 3, the value of a equal to 9, then setting x equal to -1, the value of b equal to -1. So these are the values. Just put it and integrate. Just integration of this, so integration of this, integration of this, integration of this. Clear? So for integration of already written here, integration of 4 dx, that is 4x, integration of x minus dx by x minus 3, it is ln x minus 3, and integration of dx by x plus 1, it is ln x plus 1 plus c. Clear? Now there is a special technique. If the integrand contains only even power of x in both numerator and denominator, the divide numerator and denominator by x square to simplify the integral. If it is only even power of x. So here you can check. In this example, the numerator is of degree 2 and denominator is also degree 4. So both the numerator and denominator having even power. So just divide the numerator and denominator by x square. So what we will get? It is 1, and next is your x denominator will be x square plus 1 by x square. Now rewrite the x fourth plus x square plus 1 as this: 1 by 2 x square plus 1 whole square plus x square minus 1 whole square. If I write like this, it will be the form. What will be the term? Your x square integration of this, integration of x square by x fourth plus x square plus 1 into dx is equal to 1 by 2. Okay, just see. If I divide, then we will having this type of terms. Is not it? You just see. You just divide like this and you will get, or otherwise you can take your dividing x square on both sides. Okay, just see. Okay, just check. If you cannot understand, then just ask me. I can derive. And the term here 1 by 1 plus x, 1 minus 1 by x square, then x minus 1 by x square, x plus 1 by x. Just put u and v. So if u equal to x minus 1 by x, v equal to x plus 1 by x, then du will be 1 plus 1 by x square dx, v will be 1 minus 1 by x square dx. Clear? So here this is your term, what is in the numerator. What is in the numerator? So your integration will be reduced to du by square plus 3, then dv by v square minus 1, which is easily integrable. We have direct formula to integrate these terms. Okay, these are the integration values. Integration of du by square plus 3, that is tan inverse, and 1 is ln v minus 1 by v plus 1, and put the values here. So this is the result. Clear? So another question is there. Since denominator is contains only if in power of x, we use suitable algebraic decomposition. That means dx by 1 plus x fourth. You just see. If I write 1 by 1 plus x fourth is equal to 1 by 2, like this. X square plus 1 divided by x fourth plus 1 minus x square minus 1 divided by x fourth plus 1. Okay, if you check here, if you subtract it, the final result will be 1 by x fourth plus 1. Okay, so integration of 1 by x fourth 1 plus 1 by 1 plus x fourth will be equal to integration of x square by x fourth plus 1, and another is integration of 1 by 2 into integration of x square minus 1 divided by x fourth plus 1 dx. Is not it? And if I divide x square on numerator and denominator, divide numerator and denominator by x square, so I will get this type of term. And if I put x minus 1 by x and okay, so put x minus 1 by x as u and x plus 1 by x as v, then your d will be this. As in the previous question, du will be this, dv will be this, and the result means integration of original function will be reduced to these two, du by square plus 2 and dv by v square minus 2, and just integrate these two and we will get the final answer. Tan inverse u by root 2. This is the direct formula. Just remember these two formula. Already we have discussed these formulas, and we can directly integrate. This is the final answer. Clear? Is there any doubt? Just tell me. Okay. This is the summary. This is the summary that convert improper fraction to proper ones first, then decompose using partial fractions, and after that choose the form based on factor of denominator, if whether it is linear or whether it is quadratic or whether it is product of linear and quadratic, okay, or repeated linear factors or repeated quadratic factors. So what may be the form of the denominator, then choose the right form so that we can decompose easily, and after decomposition integrate term by term to get the final answer. So this is the summary of the partial fraction or integration of improper fractions or integration of proper fraction using partial fraction. Okay, using partial fraction we can integrate like this. So it is a very important method. Just practice this type of question, and definitely you will get this type of question in your exam. Okay, thank you everyone. Again we will meet in the next class. Thank you.